Hello students, today we are going to discuss the lesson aldehydes, ketones and carboxylic acids. In this video I have discussed 10 question answers since this is a very lengthy lesson, so I am going to make a few parts of it. So let's begin with the PYQs here. What is the action of the following reagent on acetaldehyde? And the reagent is sodium bisulfite. So here we are going to draw the structure of acetaldehyde first. So this is acetaldehyde. This is being treated with a sodium hydrogen sulfide or sodium bisulfite. Now the hydrogen being electropositive will go and get bonded to oxygen, which is electronegative, and SO3Na will get bonded across the carbon atom, so that we get over here OH and here SO3Na. This compound is an addition product which is called as an adduct, and the name is acetaldehyde sodium bisulfite. Let's move on to the next one. How will you obtain propane 2-one using CH3CN? Now propane 2-one is nothing but acetone, and the structure of acetone is having 3 carbon atoms. Methyl cyanide, whereas, is having only 2 carbon atoms. This clearly indicates that we should be using a Grignard reagent to increase the number of carbon atoms, and which is methyl magnesium chloride. So when we treat methyl magnesium chloride with methyl cyanide or ethane nitrile, or we can also call it as acetonitrile, what we get is an intermediate which on hydrolysis is giving us acetone plus ammonia and magnesium hydroxychloride. Let's move on to the next question. What is the action of the following reagents on propane 2-one? The first reagent being hydrogen cyanide. So let's see hydrogen cyanide, how it is getting added across the carbonyl, carbon and oxygen. So the double bond breaks and hydrogen gets added across the oxygen atom, and cyanide being negative gets added across carbon atom, so that we get acetone cyanohydrine. The next reagent is hydrazine. Hydrazine is NH2 bond NH2. So herein we have to remove a molecule of water, and the carbon double bond nitrogen bond is getting formed in this case, and the compound will be named as acetone hydrazone. Let's move on to the next question. How will you prepare ethanol from 1,1 dichloroethane? In the first case, I have written the reaction in one step. You can write it in one step so that you get 1 mark. I have explained it in detail, wherein we take ethylidene dichloride or ethylidene chloride, which on hydrolysis is forming an intermediate, and the 2 chlorine atoms are being replaced by 2 OH groups. Now this compound is unstable, and so we have the removal of a water molecule, so that the final product is acetaldehyde. So it's okay even if you are skipping the intermediate and writing down the final product. Let's move on to the next one. What is the reaction of acetaldehyde with ammonical silver nitrate? So with ammonical silver nitrate, which is also called as Tollin's reagent, what we get is acetate radical. We get a silver getting formed. Now this silver actually looks very shiny, and this is also called as a silver mirror test, which is used for the identification of the group, functional group aldehyde. The next reagent is Fehling solution. Now when we are having Fehling solution being put into acetaldehyde, what we get is acetate ions, and we get a red colored cuprous oxide. The formation of cuprous oxide indicates the presence of an aldehydic group in the organic compound, which is under investigation. See the next one. Write a short note on Canizaro's reaction. Now this is one of the most popular question which you will be observing in the question paper. Herein it can be like asked for 2 marks or 3 marks. Sometimes, rarely, can be asked for 4 marks also. So I have tried to put all the points over here. Canizaro is a reaction which will be given by aldehydes which are having no alpha hydrogen atoms. Now the same molecule of the reactant is going to undergo oxidation as well as reduction. Now this happens in the presence of an alkali, and the reaction is called as disproportionation reaction. Now in this, one of the molecule will get reduced to alcohol and the other molecule will get oxidized to carboxylic acid, or we can also have the formation of carboxylic acid salt. See the example I have taken, one is formaldehyde. So formaldehyde will undergo oxidation as well as reduction, as I told you. So it will be reduced to alcohol, that is methyl alcohol, as well as it will get oxidized to salt. Here it is sodium formate salt, or we can also call it as sodium methanoate. The next example what I have taken is benzaldehyde. So benzaldehyde, the molecule will get reduced to benzyl alcohol, as well as it will get oxidized to potassium benzoate, which is a salt. Let's move on to the next question. Write a short note on aldol condensation. One more popular question, as you can see on the screen, it has appeared so many times. So it can be 4 marks, 3 marks or 2 marks. So I have included almost all the points here. So aldol condensation will be shown by the aldehydes or by the ketones which are containing at least one alpha hydrogen atom. This reaction occurs in the presence of a dilute base like dilute sodium hydroxide. So what is important is the alpha carbon and alpha hydrogen, and other molecule, the important is carbonyl group. So the alpha carbon will get bonded to the carbonyl carbon and the alpha hydrogen will get bonded across the carbonyl oxygen. We will be getting the formation of hydroxyaldehydes, we say, or this is also called as aldol. This aldol, further on heating, if it is having one more alpha hydrogen atom, will undergo elimination reaction. Elimination of a water molecule takes place and we get alpha beta unsaturated aldehyde. Let's move on to the next example. I have taken a ketone over here. Acetone is being taken. The important ones are the alpha carbon and alpha hydrogen, and other molecule carbonyl carbon and carbonyl oxygen. Oxygen being negative gets bonded to the alpha carbon and the carbonyl carbon gets bonded across the alpha carbon, so that we get an intermediate over here. Now this reaction can be given by ketones which are having 2 alpha hydrogens, at least 2 alpha hydrogens. So in the next step it will undergo elimination reaction so that we get the formation of a double bond. I have written all the IUPAC names over here. Let me explain one of the IUPAC nomenclature here. Observe, we are having total 5 carbons which I have put in the box. The numbering is being started from right to left, the reason being the carbonyl group which occurs at the second position. The double bond is occurring at the third position. Since there are total 5 carbons, so the parent is pentane. Now pentane, the ANA is being replaced by EN because of the presence of a double bond. 3 is the position of the double bond, so it is 3-ene. Now at the second position we are having the carbonyl group which is actually a ketonic group, so we have 2-one, and we do have a substituent over here at the 4th position. That's why it's written as a prefix here, 4-methyl pent 3-ene 2-one. I hope you have understood the nomenclature here. Let's move on to the next one. How is carbonyl group converted into CH2OH, CHOH, CH2 and COH? Let's start with the first one. Carbonyl group into CH2OH, that is primary alcoholic group. So how do we get primary alcoholic group? If aldehydes are being reduced, so we treat it with hydrogen gas in the presence of nickel or palladium, and what we get is primary alcohol. The next one is carbonyl group converted into secondary alcohol. Now when carbonyl group is present in ketones, we get the formation of secondary alcohol. So ketone is being reduced by hydrogen gas in the presence of again nickel or palladium, and we get secondary alcohols. The third one is carbonyl group is being converted to methylene group. Now this is also known as Clemenson's reduction. I have explained this further in detail in my video. So aldehydes or ketones will be undergoing reduction in the presence of zinc amalgam and concentrated HCl, so that we get the formation of methylene group and water molecules. The last one over here, carbonyl group being converted to tertiary alcohol. COH is tertiary alcohol. Now, when we have to convert carbonyl group into tertiary alcohol, we have to treat it with Grignard's reagent, that's RMgX. Mg being electropositive will get bonded across the oxygen, which is the electronegative atom. And R, that's the alkyl group, will get bonded across the carbon, carbonyl carbon. This reaction occurs in the presence of dry ether. It forms an intermediate that's called as an adduct, which further on hydrolysis gives you tertiary alcohol. Let's move on to the next question. Explain Clemenson's reduction. This is the previous one what I had discussed. Here I have taken example apart from the general reaction. Observe acetone on treatment with 4 nascent hydrogen in the presence of zinc amalgam and concentrated HCl is giving us propane. So the carbonyl group is getting reduced. The next example I have taken propione aldehyde. Again the same reagents are being taken and you are going to get the same product, that is propane. Observe the difference. In the first case I had used a ketone, whereas in the second case I had used a aldehyde. But both the ketone as well as the aldehyde are having 3 carbon atoms. Let's go to the last question of this video. How will you obtain acetaldehyde from acetaldehyde? So what we have to do is take acetaldehyde and treat it with hydroxylamine. This OH is hydroxyl, NH2 is amine. Remove a water molecule, 2 hydrogen atoms from NH2 and the oxygen atom from the carbonyl group, and bond the carbon and the nitrogen together so that we get C double bond between carbon and nitrogen. This compound is called as acetaldoxime since the parent compound is acetaldehyde. I hope you might have understood all the questions here. Hope it helps for your exams. Thank you for watching my video.